Okay, so let's solve for another problem, and in this problem, you would be determining the area bounded by the functions x squared is equal to 6 minus y, and y is equal to x. Okay, so the first thing that we need to do is to plot these functions right here in the graph for us to better visualize the problem. But if you can notice here, guys, that this parabola right here or this function right here is basically the same as with this function right here from the previous problem. So spoiler alert, its graph or its parabola would look like this. So it would be having a vertex at 0, 6, and its opening would be facing downward. So I would just be redrawing it at this slide right here. So it's not a perfect parabola. It's not a very pleasant drawing to see, but it works. So it would just look like that. So there, once again, this is to be its vertex. So 6, 0, and its opening would be facing downwards. Okay, so that is for this blue function right here. But what about for this? So let's plot for that. So our y is equal to x or our x is equal to y. So what would be the value of x if your y is equal to 0? So that is to be 0, 0. And if your x is equal to 1, your y is also equal to 1. If your x is equal to negative 1, your y is also equal to negative 1. Basically, x is equal to y. So your line would now look like this one right here. So this is to be our line. So once again, we are to determine the area bounded by these functions right here and, well, bounded by this line right here and this parabola right here, which is, well, this shaded area right here. So how can we solve for it? So once again, the first thing that we would be doing is to assign for a differential area. So let's say I would be assigning a vertical differential area. So from that, this is now to be the value for your y, and this is now to be the value for your dx. But take note, guys, that we actually have a catch here. So if this is to be your differential area, so by the way, guys, that this value right here is to be equal to x squared is equal to 6 minus y, and if we would be transposing it, this is now to be equal to y is equal to 6 minus x squared. So I will just be erasing this part right here at the top. And this line right here is y is equal to x. Okay, so there. And once again, if we are to get this value of y right here, that is to become y upper plus y lower. Because this is to be your y upper in this part right here. This is to be your y upper. And this is to be your y lower. But take note, guys, that the value of y at this part is to be negative. So if you would be adding this y right here or your y upper plus your y lower, so if y upper plus y lower, you would basically be subtracting these values right here because this one, the value of your y at this part right here is once again negative. So from that, the correct equation for your y sub 1 is to be equal to y upper minus y lower. Once again, because this y lower right here is to be a negative value, which is this one right here. So yn, this is to be a negative value. So, okay, so it is just right for us to use this. And if we are to get the differential area here at this part right here, so let's say that this is to be our differential area. This is to be our y and this is to be our dx. And our y here, which is, well, this one right here, that is to be equal to y upper minus y lower. Since this is to be your y upper and this is to be your y lower. So that is just to be y upper minus y lower. So basically, both of these parts right here are the same. So from that, let's formulate our integration equation. So for us to get this whole area right here, our area total is to be equal to the integral of our differential area with this one as our lower limit and this one as our upper limit. So let's say that this is to be b and this is to be a. So from b up until a. Okay, so let's determine the value of our A and our B. So what we would be doing here is that we would be equating both of these function right here for us to get these intercepts right here. Okay, so I would just be copying this to the next slide. So there. So once again, I would be equating it. So let's say that this is to be equation 1, this is to be equation 2. So I would be substituting equation 2 in equation number 1. So that is to be equal to, so x squared is equal to 6 minus y, and our y is equal to x. So 6 minus x. Transposing everything to one side, so this would become x squared plus x minus 6 is to be equal to 0. So now solving for x, so what we would be doing here is that we would be getting the factors of this polynomial right here. So that is to become, so x and x. So what are to be the factors of 6? That if you would be adding them, you would just be arriving at an answer of 1. So that is to be equal to, so positive 3 and negative 2. So if you would be multiplying positive 3 and negative 2, you would be arriving at an answer of negative 6. And if you would be adding 3 and negative 2, you would be arriving at an answer of 1. So that is to be our answer. And for us to determine the values of x in this part right here, we would be equating both of these factors right here by 0. So x plus 3 is equal to 0, and from that our x is equal to negative 3. So this is to be our first value of x. And as for the other, x minus 2 is equal to 0, well, which is this one right here. So transposing, you would be arriving at an answer of x is equal to 2. So there. So meaning this limit right here is negative 3, and this one right here is positive 2. Well, from both of this right here. So that is to be for the value of our x. So this is to be x. So this is to be negative 3. And this one right here is to be positive 2. So meaning our limits now would become, so the area total is to be equal to the integral of dA from negative 3 to positive 2. And once again, our dA is equal to, so that is to be y times dx, but our y is equal to y upper minus y lower. So from that, this is now to be the integral of negative 3 up until 2 y upper minus y lower times d of x. So this y upper right here is basically this one right here, which is 6 minus x squared. So 6 minus x squared. And as for our y lower, that is to be this value right here, which is y is equal to x. So this one right here is to be y is equal to x. Okay, so there, and getting the answer here. So this is now to be equal to the integral of 6 minus x squared minus x, of course, times dx. So what we would be doing next is that we would be integrating this function right here. This can be rewritten as the integral of 6 dx minus the integral of x squared dx minus the integral of x dx. Of course, all with the limits of negative 3 to 2. Okay, so from that, this is now to be equal to, so 6x minus what is to be the integral of this one right here. So x cubed over 3, of course, with the limits of negative 3 to 2, minus what is to be the integral of x dx, that is to be x squared over 2. So I have just used our power formula here. So this is from the limits negative 3 to 2. So I would just be rewriting this one right here to be considered as a whole. So this is now to be equal to 6x minus x cubed over 3 minus x squared over 2, all with the limit of negative 3 up until 2. So, okay, so let's say that This is to be our lower limit, and this one right here is to be our upper limit. So from that, this is now to be equal to 6 times 2 minus 2 cubed over 3 minus 2 squared over 2. So that is for our upper limit. So we would be subtracting our lower limit. So for our lower limit, that is to become 6x. So where's that? 6 times negative 3 minus negative 3 cubed over 3 minus negative 3 squared over 2. So I'm sorry, it is to be this one right here. So negative 3 squared over 2. So with the aid of my calculator to your left, our answer here would now become, so 6 times 2. 125 over 6 unit squared. Or, if you want your answer to be in decimal form, your answer is equal to 20.83 unit squared. So this is to be the area of this particular area right here, which is, well, this whole area right here. So there.